Hello students, in this video we are going to start a new chapter, that is area and volume. Okay, so in this video we shall only discuss about the area of the different polygons. Okay, and we shall discuss about the volume. So now here for the area we have to first know the names of the polygons. I think in previous classes you have studied about the polygons. Okay, so just surfacely I will write down the names of the polygons and I will write down the area of that polygons. What will be the formula for that polygon? So first one here. Okay, so now here triangle. Now area of triangle that will be, that equals half base into height. Okay, so now this half base into height, which one is the base, which one is the height, we have to consider that one. We have to think that which one will be the base and which one will be the height. So for that I'm going to construct a triangle and I will make it clear from that figure. Okay, so here I'm supposing a triangle as triangle A, B and this C. This ABC forms a triangle, and from the vertex A I am going to draw a line so that this is perpendicular to this BC and let this point be D. So now here this AD is perpendicular to BC, that means this is the height, altitude. Okay, that is the perpendicular, so this becomes the height, and this perpendicular is formed in this line, that means this is perpendicular to this BC, so this BC that becomes the base and this AD that becomes the height. So this is the base and this one that is the height. Okay, now similarly second one, that is quadrilateral. So now here, what is the area of this quadrilateral? Okay, so area of quadrilateral equals what? Okay, first of all I will draw a figure, and from that figure I will explain that one, how the formula that has been developed. Okay, so quadrilateral, that means a closed figure bounded by 4 line segment. Okay, suppose that I have constructed like this. Now here it has the 4 line segment and it is a closed figure. So now what will be the area of this figure? So now I am going to draw a diagonal. Okay, so that it can divide the given figure in 2 triangles. Okay, so I'm either I can draw like this or like this. Anyway I can draw that one, so that I have to form it as the triangle. So let me draw like this. I'm drawn like this, and from this vertex I'm going to draw a perpendicular line, this one, and similarly from this vertex also I am going to draw a perpendicular line like this. Okay, so now here this is A, B, C and D. So now if you consider the triangle ABD, this triangle, then we find that this BD that is supposes to be a base, because here this A and P and let it be Q. This AP is perpendicular to this BD, that means this line segment that occurs as the base and this AP that occurs as the height. And similarly now if you consider this triangle BCD, then for this triangle this QC, that is the altitude, that means the height, perpendicular, and this BD that is the base. So if we add the area of this triangle plus this one, we can get the area of this whole figure. Suppose that I am going to consider this as the h1. That means the height of this AP, that is, and similarly the height of this QC, let it be h2, and this BD, that is the base. Okay, so this one. So what will be the area? That means area of this triangle. So half base, that is, okay, I'm going to write, okay, BD into height, that is AP, half BD into AP, that is the area of this triangle, plus half, that means now we are going to add the area of this triangle. So half, what is the base? First we find the base as BD. So BD into, and height, that is QC. Okay, so this is the, now in both, okay, let me consider that BD, that is the base. Okay, I will write it the same. In both, what do we find common? That is 1 by 2 BD, that is the common, and remaining value, that is AP, and here plus. Here also 1 by 2 BD, here also 1 by 2 BD. So I have taken this as the common, 1 by 2 BD. And here we find this remaining value, that is AP, here this plus, and this QC. Okay, so half this BD, that is the base. Here this BD, that is the base. So we can write here base or anything else, or this BD, whatever the name is given. And here AP, what is the value of this AP? H1, and QC H2. So its value is like this. So we can also write it as half base and H1 plus H2. That means sum of these perpendicular lines. So this is the area of quadrilateral. Here this base, that means here for this figure, that is BD, and for another figure or a given question, the name may be different. So you have to consider that this is the base. So base into sum of the perpendicular lines. Okay. Okay, now area of that parallelogram. So now how to find the area of parallelogram? So this I will explain all this. I will write all this. I will explain that one. Okay. So number 3, that is parallelogram. Okay. First draw figure of parallelogram. Suppose that this is a parallelogram. In parallelogram, we know that opposite sides are equal as well as parallel. That means this side, that is equal to this one and parallel to this one also. Similarly, this side is equal to this one and parallel to this. Let it be P, Q, R, yes. Now suppose that the name of this parallelogram, that is PQRS. This one is parallel to this one. This is equal to this one. Similarly, this is parallel to this one. This side is equal to this one. It is a parallelogram. Okay. So now here, if I draw a diagonal so that it can bisect the given parallelogram in two equal parts, I am going to draw a diagonal. Suppose that I have drawn this diagonal. Now this triangle and this triangle both are similar. That means they are equally divided into equal parts. That means this part and this part, both parts that are same in area. They have the same area. Okay. So now here, now if we consider separately if we consider the figure, then we find that here we have the two triangles. That is triangle PSR and PQR. We have these two triangles. So now we have to find the area of this individual triangles. Now how to find the area? Okay. So here we find that we don't have the height in this figure. So we have to consider a height from any vertex. either from this one, this one, this one, this one. From any vertex, you have to draw perpendicular line. Suppose that I am going to draw a perpendicular line from this point vertex, that is P, like this. That is perpendicular, and let it be M. Okay. So now I have drawn that this PM is perpendicular to this SR. Okay. So now here I have to find now this height of this triangle and the height of this whole figure, that are the same. That is same. It means that the height of this triangle will be same as the height for this triangle, because both these triangles, they are similar. That means they have the equal area, they are similar. Okay. And whatever the height that we got in this triangle, it has also the same height. So we have to take this PM as the height for this triangle also. For both triangles, the height, that is the PM. Okay. So I am writing here, yes, let it denote the height of this triangle. Okay. So now here, area of parallelogram. Parallelogram. What is the name of this parallelogram? That is PQRS. So right here, PQRS. Okay, equals. Now we have to find the area. So we find here that areas. Okay. So now what are the areas of this triangle? Area of triangle PQR plus area of triangle PSR. I've written both the triangle and I'm going to find the area of both this triangle. Okay. So now here, if we consider the triangle PQR, then for that we have to think which one is the base and which one is the height. We have to be clear for that one. Okay. I told you that this is the height for both these triangles. So here this PM is the height for this triangle. It means that this height will be the same for this also. So I will write that half height. What is the height? PM. And now don't be confused that. Don't think that from this R, if we draw like this, then its name will be R and something else. Don't be confused. Okay. I can write the same name for this triangle also, because they have the same height. Okay. So it doesn't mean that we have to write the same name from this vertex. Okay. We can directly change it. That means we can write here the height PM for this triangle also. So I have directly written half PM. PM, that is the height, and half, this is the height, and what is the base? This is the perpendicular line, and that can be formed to this line. This perpendicular line that can be formed to this. So PM into PQ. Okay. This is the base and this is the height. You can write PQ into PM or PM into PQ. It doesn't matter. And plus, now we have to find the area of triangle PSR. Now in this figure we are completely given and we are clear about this, that this SR, that is the base. So half base, that is SR, into height, that is PM. Okay. So now in both, if we add this both, then first of all let me take out the common. So what is common in both? Half PM. Half PM, that is common, and here PQ plus yes, I got this one. So here half, I have denoted this PM as the height, so H, and this PQ and SR. Now this PQ and SR. So what is this? Both are same. Okay, we can also replace this one. Here this SR and this PQ, they are equal. So PQ plus, in fact I can write PQ because in parallelogram opposite sides are equal also. So I have replaced this SR as PQ. You can also okay, I will replace PQ as SR. SR plus SR. You can replace anyone, it doesn't matter. Okay, you can also write PQ plus PQ or SR plus SR. Why I have written here SR? It will be easy for you to understand this one. Okay, if we consider this as the base. So half height and SR plus SR, it will be 2SR. So 2 cancel. So height into this SR, that is the what? Base. So SR base. So okay, this BH, where B equals base and H equals height. So base into height, that is the area of parallelogram. Okay, thank you class.